Hi, this is Zhiqi. In Module 12, we talk about the corrosion. In this lecture, we're going to talk about what favors the corrosion and what is the corrosion, why corrosion is horrible, and how to fight against this. In the end, we're going to get a little bit of practice. So what favors the corrosion? This actually reminds me of an experiment I've done in high school to detect what influenced the iron nail to be rusted. We have three groups. In the first group, we put the nail fully inside of the tube with the boiled water, which is to remove the oxygen inside of the water. In the second group, we put the nail inside of the tube and with calcium chloride to remove the water vapor from the air. In the third group, we put half of the nail inside of water and half contact with the air. So in the end, we find the third group, the nail gets rusted. So we can know the nail could react with both water and oxygen. In terms of this, there are three main ways could favor the corrosion. The first is the weather condition. When the metal is exposed in the environment with water, wind, and moisture, it's gonna quickly oxidize. And also it's up to the region. When the metal is corroded faster near the coastal regions, the salty water and so much humidity and moisture can influence the metals. The third is neglect. When we fail to take care of our metal products, and we could find them just very fast corroded. So what is the corrosion? Actually, the corrosion is unwanted volcanic cells. It's kind of common cells. As we see here, when the water contacted directly to the ion, on the anode side, we can see the Fe lose electron, and on the cathode side, we see oxygen and water react with the electron to form the OH minus. And here the cell bridge is built and the circle is formed. Later, the FeOH2 formed with the oxygen and water, and then with water again to form the Fe2O3, which is a deep red powder, and which is called rust. Here we can see the all reacting functions of the rusting, of the corrosion. Why corrosion is such horrible? According to the Federal Highway Administration, there is approximately $276 billion is costed by the corrosion, and globally, each country takes 4% of their GDPs to fight against the corrosions, which is a huge amount of money. And what's more, the corrosion can cause injury and death. Let's take Bhopal, India as example. In 1984, the steel pipes corroded, and some toxic demisol leaked, kills over 15,000 people, and 500,000 just suffered directly or indirectly from this disorder. And there are also two ways about how the corrosion influences the transportation and agricultures. So how to fight against the corrosion? There are 6 main ways right now in the industry: metal tap, protective coating, environmental measure, sacrificing coating, design modification, and corrosion inhibitor. In terms of the metal tap, we could use a corrosion-resistant steel, such as aluminum or the stainless steel. Like the rim for the cars, especially for the off-roading car, they prefer to use aluminum and to reduce the corrosion. And also for the cooking stuff. Then we talk about protective coating. There are also two ways for this. First is oil painting. It's commonly used in the petrol industry to put a cover on the tube to protect the transfer of the electrons. Second one is called bluing. It's commonly used in the ancient weapon production, like sword or cannons. So when people heated the iron up to very high temperature, they spray the water on the surface of this. The water is quickly divided by the high temperature into oxygen and hydrogen. Fe then formed with oxygen into the Fe3O4, which is magnet. A very thin layer of magnet is covered on the surface of the sword, and it plays a very important role against the corrosion. Here is the overall functions. The last one I want to talk about is the sacrificing coating. As we have seen in the electron potential form, the metals with the lower electron potential is easier to lose electron, and with higher it's harder. So if we put the zinc on the cover of the iron, the zinc is easier to lose electron. So zinc is easier to form the Zn2 plus. The electron which should the iron to lose is lost by the zinc. So they sacrifice the zinc to protect the iron. This process could also make a connection with a sacrificed anode by a cable to the one we want to protect it, and also accelerated and maintained by using a battery. As we have seen, the Google has put this service terminal in the deep ocean, and they use this kind of way to protect the metal on the surface of the service terminal. And here is the reaction we have seen. Let's take a little bit of practice. Which of the following metal could be used as a sacrificing coating on the iron to prevent the rusted forming? Sm, Pt, Cu, Pb, or Al. By comparing the electron potential form, we can find the position of Fe. Then we can compare the electron potential of our candidates with Fe. We have seen that Sm, Pb, Cu, or the Pt has higher electron potentials, and it's not that easy to lose electron. Only the aluminum has a lower electron potential. So we can say that aluminum is easier to lose electron than Fe. So if we cover the aluminum on the surface of Fe, the electron of the aluminum will transfer inside of Fe. Then the aluminum will be sacrificed to protect the complement of the Fe. And the oxidized and rusted is formed here. Here's all for the presentation. I hope you can enjoy it. Thanks so much.